Does that sound okay? Yeah, it's okay. Oh, I know, like in my mouth, yeah. All right, guys. Pipe down out there. Okay, well, we'll get going. This is the first talk here. We got what can you build? Developing or Heatpunk product development. This is cannot be more excited, to be honest. The products these guys have are absolutely amazing. From last year to this year, this is incredible to see. And I think I just yeah, we'll start with Dane. We'll get a round of applause before we get going here, Dane. But I want a round of applause for Dane and Michael. These are the guys who've got this hash tub in the back, which is just an incredible device. So let's give this guy a round of applause.
I mean, it's kind of like Tyler was going with. We had the steampunk version. I did love that last year.
Yeah, last year was
Last year was awesome.
Sure, last year
we're
was
mature. We're trying to mature.
It is. We're
now.
maturing. Yeah. For those of you that weren't here, we were in 3, like stock tank cowboy hot tubs, and they were pretty much like lobster pots. They were probably dangerously hot at some points, but they did work. So it was a proof of concept. But Dane, I want to start with you. You've developed the hash tub out here in conjunction with Snorkel. It's, from what I understand, you're using a ASIC to hash and to heat this with Hashrate, but you're also using a resistance coil, which does not pass the purity test. So my question is, how dare you, Dane?
Which is great, and I want to kind of go with that too. Give Alex some crap here, because I remember his first, I don't know if it still is with the Heatbit, but I was like, wait, it's a Bitcoin, why does he have a resistive coil in here? Like, this is silly. But then, kind of.
Then you're talking about the second one, actually.
Yeah, okay, thank you. Correction. And it's kind of one of those, there's a use case where, you can heat that hot tub purely with just a Bitcoin miner. But from just the infrastructure point, and just like Tyler was saying too, it's, 1 watt in of energy is 1 watt out of heat. 1 miner is about 4,000 watts. So, if you have a small tub, 4,000 watts is more than enough to heat a small tub. A bigger one, it takes a little more than that. But it also adds kind of that ease into people of kind of the segue, the gateway drug of it, right? It's like that safety net. It's like, hey, there's still a resistive heater. If for some reason all goes wrong, you can still heat your hot tub. But ultimately, it was built on the idea of vacation rentals and things like that, where they turn their tub way down, and like the miner can keep it at that temperature, but then they want to turn it up overnight and want to heat it up for their clients. It helps give that extra boost to heat it up. And it's all done just with a little dip switch, so it's totally user configurable. You can turn it so the resistive coil never comes on, but if you fill it up with 50-degree water and you want to heat it up really quick so you can bathe in it that night, you can turn it up to say, hey, resistive coil, shut off at 90 Fahrenheit, 100 Fahrenheit, 80, whatever you want, and then the miner will take over the top off. And then the miner just runs to keep it constant, because once you heat it up, you just need a little bit of heat to keep it going. So that's kind of was the design consideration.
Okay. All right.
But you can keep it, you got purity mode if you want.
Yeah, design consideration, your words, not mine, Dane. How dare you? No, I think this is really interesting, because it is like doesn't pass the purity test, right? Dane's got a product that's using a resistive coil to heat, but because he has this demand profile that it looks very flat and it's great for a miner, but every once in a while when you change that water, you have these extreme spikes, but then they come right back down. So to install, correct me if I'm wrong, but to install 2 miners, the extra cost to have that extra miner there to only work at this tiny narrow band once every couple months just doesn't make sense. So it's cool to see that there is these pragmatic approaches to.
Yeah, and it's kind of like you said, it's purely a cost-based thing. Like a resistive coil, it's hard. You're kind of beating on that. It's a it's a $50, $100 part. It's like that's hard to argue when you're building in a whole system. So really, you only need that 4,000 watts to keep it going. But yeah, that small spike, it's not really worth putting a whole new miner in. So
yeah, very cool. Well, I think what you're doing over there is awesome, and it seems to work fantastically. I mean, it's been perfect since it's been in. Alex, I want to take it over to you next. Can you just give us a rundown of what you guys are building, and maybe what products you have now, and maybe kind of explain this Canvas product that you guys have?
Okay, thanks. So by the way, thanks for putting this together. Like I missed it last year, and I was gutted I missed it. Now I managed to make it here. I think it's an amazing thing that you're building. Thanks for that. Thanks, Tyler. So products, space heaters that mine Bitcoin. Like that's kind of how it started with our first device back in 2020. which kind of started out of boredom, but I can go into it another time. So yeah, the first one was actually in repackaged S9. We kind of made it easy to use, and it was kind of plug and play S9. You didn't need to know much about mining to actually start using it. Because it was a repackaged S9, it actually didn't work very well. And I think a lot of people here on the panel could share some of the pains of dealing with like an existing hash board that you get from Antminer or any other miner. As a result of that, we're like, well, you can't kind of build devices around an existing miner. It's just very tough. It becomes bulky, and you kind of have to fit into the industrial miner design decisions that Antminer Bitmain has done some while ago. So we're like, okay, let's build another one. And we built the Trio. And that's the one where, like, exactly the same considerations that we had where, well, let's have part of the heat coming from the miner so that you could have it as some sort of a base load, so you increase the utilization, I think is the word I'd use. So you utilize it as much as possible. And then for the days where it gets really cold, you have the resistive heat. That is cheap to add, and maybe you use it, I don't know, 5 days in the whole winter, but like you don't feel cold. Mm-hmm. So it's exactly the same consideration. That's the economics of it. And also we didn't have this, like what if the miner breaks down kind of consideration for the Trio, but just the economics was enough to make it that way. Then the next one was the Maxi, when we're like, well, let's build something that actually passes the purity test. And for the same amount of power, 1400 watts, we just put in loads of mining chips, right? There's, but one difficult part to build the product was actually to have the power supply unit. So for the power supplies, one, there's not that many that are that powerful that you can use in a residential setting. And two, if a power supply is very powerful, it can actually have very high radiation, right? So, and FCC may be unhappy with it. So instead of using one very powerful power supply, and Maxi is 1500 watts, we're actually using two 1 kilowatt power supplies inside, and loads of S19J Pro chip with the PCB, the miner that we designed ourselves. And the way that we design, and the reason that you have to start designing your own PCBs at some point is you have a lot of safety considerations, which are very different between the industrial miners and the stuff that you want to use at home. Like it's kind of hard to get a UL with an Antminer board inside that you didn't design. Right, someone like TUV or someone like Intertech will ask you like, hey, give us the PCB design files, and you can't because it's not your design. It's Bitmain's design. So it's possible to get around it, but it's hard. And then the safety consideration is the biggest thing there. And then the latest one, it was actually just conceived as an idea about a year ago. I think in March last year, it was just an idea, and we were kind of bouncing around the ideas with our CTO, and then like the first radiant heaters that mine Bitcoin were put together, I think, around mid-March last year. And then towards the end of last year, beginning of this year, we launched it as a commercial product. That's something called Heatbit Canvas. It's a infrared panel. So it's about, you can see it upstairs. Like it's an infrared panel about this size. It's just a black square that you put on the wall, like about the size of this painting, slightly bigger. It's all black, and it heats to around 80 degrees Celsius, and it radiates the infrared radiation towards you, heating your body. It doesn't heat the air so much. It heats the body. In terms of electricity to heat, it's the same efficiency like any other miner, like 1-to-1 basically conversion. But in terms of the way how you deliver the heat from the source of heat to the ultimate consumer, which is your skin, it's different. The radiant heater is a lot more efficient than the normal convection heaters. For a convection heater, you basically need to heat the volume. Like you would need to heat the air in the whole of this room here to feel warm. And also, most of the hot air would actually end up at the ceiling where we don't feel it. Whereas with radiant heat, it goes directly to you. It works much faster. You don't need to heat the whole area. And from the engineering standpoint, it's wonderful because you actually don't need any fan. For the regular space heaters, there's normally some sort of a fan to kind of increase that airflow. For the radiant heat, you don't need a fan, which means it's cheaper, which means there's no noise. So, how many silent Bitcoin miners are out there? Well, now with water cooling, I guess a few more.
Yeah, I would
But
say
for
how many non-liquid cooled miners?
Yeah,
that are
non-liquid
silent?
cooled
I
miners,
don't know,
probably not
any.
many, but this is the way where you can just have this in your room and don't even know that there is a Bitcoin miner.
Yeah. So this, I had a recent experience that reminded me of what Alex is doing. We talked earlier about this. In the traditional like HVAC space, we have what's called cove heaters, which act in the exact same way as Alex's device. When I plugged it in, I immediately felt the heat like coming off this thing upstairs. And I just installed like 6 of these heaters into a house because I didn't know there, well, at the time there wasn't an option. So, but they're doing the same thing. I think that you could easily repurpose what you're doing. This technology you're using could be a direct swap over into cove heaters, which are being used all over the Western United States in houses currently. And they're just resistive electric heating, which is the greatest use case. Like the easiest target for us to target is people that are already using electric heat. If you're already using electric heat, there is zero reason you should not be mining Bitcoin with it. Like if you're using natural gas, that's harder. Propane, a little bit harder. But if you're already using electric, this is a great use case. And I think like I'm really excited. Last year at the end of the conference, I said there was 2 killer products that I thought we needed. One was a water heater, which we're going to get into right now. The other was baseboard electric, which is the same as cove heating. And I think we're really onto something here with what you guys are doing with Canvas. I think it's really impressive and really cool technology.
I hope we'll get to interact, maybe, draw something.
Yeah, I think we'll have everyone sign their names. I think it'll be great. Joseph from Superheat. This is, like I said, I called this out last year as what I thought was one of the most tempting products to build for this industry. You want to tell us a little bit about what you guys are doing at Superheat and what you guys have built?
Yeah, so hey everybody, I'm Joseph Ma, co-founder of Superheat. So what we build is a water heater that mines Bitcoin, right? And it's the same principle as everybody else. It's a Bitcoin miner that runs in your water heater and transfers the heat into the water tank. Our product, we just showcased at CES a little bit earlier, a couple months ago, and it's a 50-gallon unit, 280 pounds without the water. It's about this tall, I guess. It's a huge thing, and basically we targeted the water heater to do the same thing as your regular water heater would do. So the 50-gallon was the thing, and then the 3.3 kilowatt power input was also, trying to directly compare it to regular water heaters, and the pipe layouts, the input in the water inlet, water outlet, everything was standard, so that we wanted to mitigate the friction for installers to install it as little as possible, so that they can, every plumber will be able to install the unit in any houses. And since we talked about purity, we also have a resistive coil in there, but
okay.
That is more of a fail-safe for us. So when the miner goes down, you still have hot water. Basically.
Okay. Again, very pragmatic approach. I think that's very smart.
Yeah.
Given the low cost of electric resistance coil, that's actually a really clever move to have it as a backup, as a fail-safe.
Yeah. So also what Alex alluded to earlier, we also had problems with using right off the shelf miners in there, the hash board. So we kind of our prototype was using What's Miner M50 in there, and we ended up starting to design our own boards as well because it was so hard to control. And I sometimes wish that we can regulate the power without turning it off and on again. So it can have different power envelopes.
Are you guys then, Alex? You're building from the chip level. You guys you're buying like the literal chip, and then you're just designing everything from there up. Are you guys doing some kind of like hybrid of this at at Superheat, or where are you at now on your device? Is it you're not buying individual chips and building all the boards from there, or are you kind of modifying existing miners? Modifying M50Ss.
Right now, we're basically buying boards, and then we're working off of that.
Okay.
We have a separate, kind of a daughter board. That
we're like a stage, different stages here, I guess. And
yeah.
so you guys you're buying just the boards and then changing the form factor, but not changing the boards
Yes,
themselves.
we're working on changing the board because that's so hard to work with. Yeah.
Okay. Very interesting. And what what efficiency miner are you guys using in here? You made the decision. It's like is it an M50? Is that roughly?
Yeah, it's around M50. We tried different like a couple of miners, but we landed on that. Yeah.
You landed on the M50. What was the reasoning for the M50?
We feel like it's right at the brink of being profitable on its own.
Okay.
But it's not super expensive to source, and we wanted to target a price point where you basically have price parity with the existing water heaters.
Mm-hmm.
Yeah.
Okay, so you don't want the initial cost to be so high.
Yeah.
Yeah, this is an interesting thing. It seems like when you run a lot of these numbers, there's a sweet spot for hash rate heating in this low end. Like one of our superpowers might be. I think there's different cases for this. But it might be that when the big miners can't use, or these old miners become inefficient, nobody else will buy them. There's like not a market. There's no secondhand market. It's just like either they make profit at 4-cent power or they don't. And if they don't, there's like they're worth nothing. And then they trickle down. And crazy enough, there are new machines that are still out there that didn't get used for whatever reason. So it's not like you have to use these beat up old boards. It's like there are M50Ss that are brand new somehow still around. So that's yeah, I like that a lot. What do you guys have for upgradability with Superheat? Is there a way to like upgrade, assuming down the line?
Yeah, definitely. And I think one of the things that we had to worry about is that water heaters typically last 10 to 15 years, right? People people don't change out water heaters out of a whim, right? And also water heaters are not an impulse buy. You basically talk with your plumber, you talk with your contractor, and you decide what water heater.
Can you pull the mic just a little closer?
Oh, okay. Oh, this is better? Yeah, sorry about that. So, so like I said, water heaters need to last at least a decade. And most water heaters, they provide 10, 12 years of warranty, and we want to do that. So we're providing 10 years of warranty too. But the problem is that when you buy these boards or buy these miners from, producers, their warranty are 5 years. So, like in our design, we basically, our design principle is that plumbing needs to outlast compute, because plumbing needs to live for a decade, and then compute will probably need to be upgraded in 5 years. So I have a couple booklets in my backpack I can share with you guys, but basically we have thumb screws on where our miner is. You like take off 4 thumb screws, and you can slide out the compute module and put in a new one. And that's basically how we designed it, so that people can upgrade it even when it breaks. It's a very easy repair, so that we don't have we don't need geniuses to service those.
Okay. Yeah. Amazing. I think what you guys have developed is really good. I'm very impressed. Dane, I want to go to you. Nicholas here on the end. I'm gonna get to you, Nicholas. All right. It's a big panel. You're gonna be the caboose on this train. All right. But before we get down there, I wanted to go through you, Dane, as well on upgradability on that hot tub and your systems in general. Like, what is the process for upgrading, and like how far into the future can you upgrade? Yeah, and just what kind of machines are you using and why?
Yeah, definitely. I think, as these two were just alluding to, is I'm still in the camp now, chip level, board level, still kind of working with the industrial miner form factor, which is the big shoe boxes, right? And it's why it kind of looks the way it is and all that. There's a little bit nice it's easier to convince when it's a dielectric fluid and you're like, there literally is no oxygen to start a fire. This has a high flash point. There's nothing in here their immersion in itself is super safe in that aspect. But hydro is great as well. But I think what's nice, I was looking at there's only one really water-cooled 240 miner for us to use, and that's not 3-phase, right? For us to use domestically. And so Watts Miner M64, and those are great. I built a form factor around being able to replace your hot water heating element. It's like a 24 or 10-inch by 24-inch round disc you could place your hot water heater on, and it's kind of under the same context as Superheat, but I was thinking in my mind, like, you don't have to replace the whole water heater most of the time. Like, a lot of times people, it's like their board goes out or their heating element goes out and it still can hold water. So I built a form factor around an M64, but it's shoe-hold to an M64. If they make an M74, maybe, but they launched the 70 series, and there is no M74 right now. So it's kind of, you're stuck with one miner. But what I really like with immersion is you have a handful of generations you can change out that miner, and it's still the heater heating the liquid, and your liquid's that medium that can be pumped anywhere. So it's nice because you can put a S19J Pro still at $200. You can get those now, right?
Yeah.
I bought them at 10 grand back in 2020.
Yeah.
You know, so
Yeah.
it's the like fact of the network and the way it goes, right? Like, it's interesting to even say that, and just like to the people out there who are new to this, like that's what happens. But you run them full time and you get that Bitcoin back, but you have to run it all the time to, if you buy a new miner, it has to be uptime to be able to ROI that.
Yeah.
Where if you buy an S19 right now, the network difficulty is way different, but it's $200.
Yeah.
If you're just heating, if you're mining just for heat, that's an ROI in less than a year for that miner. You know, where if you did a brand new one, it's going to take 3, and you got to have incoming. And so,
I mean, from the data that I've done, and it's by no means
Perma-bear.
exhaustive, do your own research. What I see in the heating application with only I have a 30% uptime. If I was to put an S21 or something new in, the payoff time is never, because the first year it's 3 years, and the next year it's 4 years, and the next year it's because the decline in hash price, and also the just extreme upfront cost of these brand new miners just cannot be recouped. So at least in my applications, I'm sure there are other, it's all uptime dependent, and that's something that I love about these three. You guys, all three of you actually, are replacing products that are high enough uptime. These are pretty high uptime. People run space heaters. I know a lady who runs hers year round. Like in the summer, she has the air conditioning running and her space heater running.
oh my God.
We have actually a good number of our users.
Yeah. I mean, you live in a house.
I'm kind of wondering if they use someone else's electricity.
I don't know, but or they don't care. But she lives in the basement of her house, and the air conditioning. It's cold down there, and she has the space heater next to her desk, and it's like, all right. And then water heaters run everywhere all year round, all the time. I mean, they don't run every second of every day, but it's a year-round uptime, which helps recoup the cost of these things. And the hot tub, again,
Yeah, hot tub, it's amazing actually how long a heater runs in a hot tub, actually. It's pretty consistent, really.
Yeah. No,
and that's what's nice with the miner scaling, is it can scale up and down to kind of meet, depending on the bather load or the temperature outside and stuff like that. I think one last bit, too, just quick product plug, I guess you'd call it, but
Dane.
on that heater, the M64, it's tough, but it's like you're saying, the uptime of a hot water heater is kind of the same. It's like it's on and off, but once that it's heated, it really doesn't lose that much heat in your hot water heater. So we did it's got two heat exchangers, so you can then dump the heat. If you want to dump the heat and you're in an amazing place and you want to mine all the time, you can dump it outside, but it's more based around being able to plug it directly into hydronics. So it's kind of you can replace your hot water heating element, but then also treat your hot water heater now as your furnace or your radiant floor.
Like a combi boiler, I guess.
Yeah,
is sort of
exactly. So it's kind of a 2-for-1 type of deal. Is the hopes because of that uptime, trying to just keep the uptime on those miners.
So the thing I love, the other thing that I see in common with you three, which I love, is that you're not competing with alternate fuel sources. Like you guys, Heatbit is creating things that are always electric. No one's going to plumb a gas line under their desk to run a natural gas heater, even though it's cheaper to run. It's not going to happen. So you're not having to go toe to toe with these cheaper fuel sources. And electric water heaters, oddly enough, America's filled with electric water heaters. Natural gas is far cheaper to operate, but because of installation constraints and ease and all these other reasons, cost probably, we use electric water heaters all over America, even though we do have natural gas, which is a cheaper option. That's a little harder with furnaces and things like that. And Dane, same way. The bulk of hot tubs in America are electric, and I don't know exactly why, but they are. So you're going toe to toe, not with a competitive fuel source, but with a like kind fuel source. So it just makes it such a slam dunk, for these things. But now it's time for Nicholas. Nicholas is taking a different approach, I would say. Nicholas, what have you been up to for the last year? I mean, give these guys, some of the people here probably don't know what it is you're up to, but so give them a rundown of what you're doing. What have you been up to for the last year?
Yeah, so for those who don't know me, Nicholas, I'm the founder of Constellation Heating. Might sound like a crazy name for a Bitcoin heating application, but the idea came from when I was looking at big warehouses filled with miners. I was like, this is so much wasted heat, but they're generating so much revenue from helping balancing the grid. So the idea was just like Dane explained, we have very similar system. The only difference though is the idea, we have a platform staying on.
Yeah.
So we have a platform sitting on top of all those heaters so they can talk to each other. That's the constellation of all the heaters. And when you reach a certain level of hash rate and power consumption, well, the grid is interested working with you for offering grid services. So balancing the grid just like they do in Texas. So the idea is to bring back mining into homes. Ideally, put a node on that, so you have your miners, you have your node, and then you help balance the grid. So basically, all the technical stuff Dane is doing, we're trying to do as well as he does, but on top, we just add a software platform that helps connect to the power grid.
So,
which is huge.
Yeah.
Which is so huge if you can get your constellation of all these out, right? Is the idea.
Well, there's a big hurdle. I mean, we need to reach a level. You cannot do that with 1 or 2 or 3 miners. You need like 100 miners in certain location. They're usually for a utility is very good. I come from the utility world, so I know they need this. They typically don't like Bitcoin because they don't understand it. But once they do, they'll realize it really helps them doing what they do on a daily basis. Like balancing the grid is a tough challenge for them. So I think Bitcoin can help do that.
Can I ask a question here? So, and maybe this could be relevant to the 256 Foundation and the folks from 256 Foundation. For guys like Nicholas, for us and for many others who build in devices, it would be great to have some sort of a standard to be able to plug in to the demand response programs, because on our own, it's hard to reach that scale. But if we do it together, if we could follow the standards, then all together we could create this alternative income source for our users.
Yeah, absolutely. The idea, I mean, it's a tough challenge. So first step, we're now currently integrating with, there's like a middleman between what we call the RTOs, or one level above the utility. So we're not big enough to integrate with them directly. So there's, we call them aggregators. So they pool all their resources together and they do the interaction with the grid. But yeah, the idea is once that proof of concept works, I mean, I can take out the controller out of my heater and, like license the technology to integrate. So any miner, you don't have to have our product. You can do residential mining with your miners, but you just hook it to this box, and then you can be part of that constellation. That would be a future step, but obviously that makes a lot of sense.
So to clarify this stuff and maybe bring it back down a little, what Nicholas really is proposing here, like the grid needs sometimes to burn off excess electricity. And right now, a lot of these big mining factories down in Texas or wherever or anywhere in the country are doing this job for the grid. So we can do this theoretically at a decentralized level. Well, I guess my question though is, when they call for curtailment and then this grid says we need to burn off extra power and we're willing to pay you to do it, or we're willing to give you a very cheap rate to do it, what are your systems going to have? What if it's summertime? What if it's hot? You can't be, we can't have our machines turning on and dumping heat into the house.
Well, you gotta certify to them that the machine is working like 24/7, 12 months a year.
Okay. So you're talking about having you will guarantee to the grid that the machine can run 24/7.
Exactly. So typically, when I do an installation, they're mostly for like bigger installation, like hot tubs. Maybe we can do it, but bigger installation. So it's a radiant floor heating, and we couple that, just like Dane said, with an extra radiator outside. So
like a dry cooler.
A dry cooler,
okay.
right.
So So in the case that it's summertime and the grid says we need you to burn off, X amount of power, or we're willing to sell it to you at a half a cent, a kilowatt hour, you would then be able to have a system in place to dump the heat outside.
Absolutely. But what I try to convince the customer is the best use case is you heat your home in wintertime, you heat your pool in summertime.
That's true. Maybe
So
we all
there's
need
no
more
waste.
pools.
Yeah. But
with infinite energy come infinite pools. So
it goes the other way as well, right? Sometimes the grid needs a lot more energy, right? In Texas, what about a month ago, right? It was cold. People needed more energy, and a lot of the miners turned off the hashing so that the grid would actually have more energy. I was actually speaking to some of the big miners, and I was saying, hey, how are things going? How's the economics? Like Bitcoin dropped, and they were like, honestly, we made more money last year than if we were mining. So yeah, it's pretty big.
Yeah, from curtailment.
Quick interject too on just that idea of, okay, if you're curtailing because you need it to be warmer for people's homes, there's almost got to be a checkbox on, hey, this is actually a heater. Can we keep using our heater? You know, because I mean, there's something about that. If it's a radiant floor system, I just thought of this. Like, you know, if you do the Constellation deal, and then it's like way scope, but you still need to have that option on saying, hey, this is actually comfort heating.
There are different scenarios. Sometimes it's a long-term curtailment that you need to do, like in the example of Texas that I was talking about. Sometimes it's actually an old example from someone from the energy industry. So in Germany, when the national football team, national soccer team, forgive me, is playing.
Thank you.
So when the halftime starts, the power consumption of the whole German grid goes up by about a gigawatt. A gigawatt, okay? So one nuclear reactor power is about a gigawatt. Like that's a scale. And the reason for that is, so you know, halftime starts, people get up from their couches, go to the kitchen, and open the fridge. The light goes on. But the whole Germany does that, so that's a gigawatt.
That's awesome.
And for those like that, it's like, okay, you know, do I start another nuclear reactor, or you know, or whatever the people use in Germany now, or yeah, maybe for a couple of minutes the mining can stop. Yeah.
And that's the glory of miners, right? It's like on and off. You start, shut down, start, mine Bitcoin. It's
Because starting and stopping is a big problem for the energy grid. Like starting a power plant is not a small thing.
Unfortunately, we're going to kind of get short on time here. I would love to get into later. Nicholas and I have talked about a theory that we think hash rate heating could reduce power like costs. Just by the more of it that we do, the more the prices could go down. There's a theory on this. Find us later. We don't have time to talk about that. But it's a very interesting topic. I want to get into you guys. I want to hear from you guys. Like, what do you think the biggest pain point is in what you guys are developing? Like, if there was one thing you could change, or you know, something to like for the 256 Foundation, or just anybody. But like, what is the single thing that you're just like, God, if only this was different, it would be so much easier to build what I'm building. Nicholas, we can start with you.
Oh yeah, I'm looking at Michael over there. Like open source firmwares. I mean,
Firmware.
Well, on my case, I'm paying fees on pretty much everything I use. So paying fees with the pool, paying fees because we need an aftermarket or firmware.
Yeah.
Paying fees there, and when it comes to certification, just like Alex said earlier, when you have no idea what's inside of your machine, it's very hard to get it certified. So having access to open source hardware, firmware, that would solve a lot of problems.
All right, Dane.
I hate to just piggyback, but 1,000%. I mean, what 256 Foundation's doing is awesome. So like, I think firmware is great. Like the control board, kind of heard some digs on the Mugina control board or whatever, and like
People are
Libra. Oh, well, Libra. Thank you. See, I need to work on that still. Libra control board, but being able to have the temperature input into a control board. So like, we're all building systems where it's like, I build a system to make the miner happy and use the heat over here. They don't really talk. Like we have heat exchangers and we make it work and it works great. But it's like if you could bridge that gap to say, hey, thermostat's at 71, it needs to be 71 degrees at 69, turn up 4,000 watts.
Right.
You know, like that would be huge.
Yeah, it seems like control. I mean, in my own experience, it's the same. Control is the biggest hurdle. Like the hardware, it makes heat. That's fine.
Yeah.
It's just how do I harness this monster that
But in the 4 now, though, it's funny, we're integrating with systems where it's 24-volt contactors anyways. So they're used to just bang on the heater and bang off the heater. So it's a dream, but we make it work now.
Yeah, it works now, for sure. Joseph?
Yeah, I think pretty much the same thing. Like I said earlier, like I would like in the ideal world, I would like the miner to go, from 1,200 watts to 3,300 watts, like whenever I wanted to.
Yeah.
Like it doesn't have to shut off.
Yeah.
And basically, so like open source firmware is definitely a thing. And then I think a little bit of standardization on, the basically the communication layer, like how like Dane just said, like how the because we have multiple temperature sensors in our water tank, and the miner knows absolutely nothing about it. So we just have to. So like the miner only cares about its own chip temperature.
Yeah, that's right. This is exactly how I do my systems. It's a one input thing, and it's chip temp, and I have to extrapolate fluid temps beyond that down the line to try and then reverse engineer the chip temp to get everything to work right.
Yeah, that was a headache and a half. So like I like if we can solve that, that would be great.
Yeah, that would be great.
Yeah.
Yeah. Alex, please tell us control is not your weak point.
Okay. Control is not the weak point. I would standardization. I think there's generally in consumer electronics, there's a lot of stuff that could be standardized. In like the home assistant stuff, by the way, right? Like so that whoever here on the panel, like whatever we're building, we could just build to certain standards, and we would know that it can plug into many homes. I think that's one. I think with the access to chips and designing the hash boards, I think at some point it's going to be solved by people on this panel and many others. The other thing I would say is just communication and PR. Like let's make this kind of heating normal. Like why not?
Well, I think the products are there now, or we're very, very close to there now.
It used to be, if you think of it, about 100 years ago, maybe slightly more than 100 years ago, the normal way to light your room would be to use a little oil burner. Electricity was not the norm yet. Now it's electricity, so why can't we do the same with compute heating or Hashrate heating? I think moving it in that direction will be kind of important as well.
I think so too. I think it's. I think this year has shed a lot of light on the direction that the direction we're going and at the rate we're going seems to be both. I'm very impressed by. So let's give these guys a round of applause, and we're going to move on.